Hello everyone, this session I will cover the Scikit-Learn code for logistic regression. You know that the logistic regression is a classification techniques where my output values of categorical. So classification problem we can solve using the logistic regression. In the previous session we discussed what is logistic regression with one example. So here the objective of the logistic regression is to find the way to optimize the W here. W, you know that W is the weight or coefficient of the variable in order to reduce the classification error. Not only logistic regression, but for any classifier, the objective is to reduce the classification error. So if such a combination exists with a certain error threshold value, we say that problem is linearly separable. Means what? The meaning of this statement is what? If it is possible to reduce the loss function by optimizing or by trying the different values of alpha. In the linear model also we discussed different regularization technique. These regularization techniques, Ridge and Lasso, helps to minimize the loss function by trying the different values of alpha. So if by trying the different values of alpha, if we are getting the optimized model, then it is called as the example of linear problem. That problem is a linearly separable. On the other hand, when it is impossible, if it is impossible to find the linear classifier, the problem is called as the non-linearly separable. Means what? Even though trying the different values of alpha, if we are not getting the proper accuracy, better accuracy, means that linear regression cannot solve this problem. So we should go for the non-linear equation. Right, so that problem is called as the non-linear separable problem. Here is the best example of the logical operator XOR gate. If my data points are like this, and if we find the hyperplane to divide these data points, so any one of the data point will be misclassified. If we consider this is the true class and this is false class, so here false is the misclassified point and here true is the misclassified point. If we draw the hyperplane like this, again, one of the data points will be misclassified. So because my straight hyperplane is not suitable here to classify my data points into two separate classes, that is true and false. So the best solution can be non-linear curve, for example, like this. Right? So this curve can solve my problem. So in this left side of this curve, all the true points are there, and right side of this curve, all false points are there, right? So this is the example of non-linearly separable problem. So here is the Scikit-Learn code for the logistic regression. Like other techniques, here inbuilt class is available, logistic regression. L is capital, R is capital. So this logistic regression class is defined under which package, that is sklearn.linear_model. So again, we need to import here from sklearn.linear_model, import logistic regression class. Then create the object of this logistic regression class by using this logistic regression method. After creating this object, feed the model for the X and Y training data set. So this feed function will execute the logistic regression algorithm here. So once you will execute this code, you will get here this message which indicate my logistic regression model is created successfully. So if you want to find the score of this, accuracy of this model, there is another method, that is a score function. Right, so LR is my object name. LR.score function will return you the accuracy of this logistic regression model, and what parameter we pass to this this function, that is test X and Y tested data. So for this example, my accuracy is 91.99%. Like your linear regression model, also we can find out the intercept and coefficient values defined or written by this feed function into the object. So here are also inbuilt hyperpel parameters are there, which are similar to the linear regression model. So LR dot intercept underscore will return you the intercept value for this model, and LR dot coefficient COEF underscore will return you the coefficient value of this model. For this example, because it is a multiple linear regression example, right? Here my number of hyperplanes are 3. And that's why we are getting 3 different values of the intercept here. Here also in the coefficient, we are getting the 3 different values for the 3 different hyperplanes. And my data set is a 4-dimensional data set. And that's why there are 4 values in this array. I hope, student, you are clear with this. And like your linear regression model, we can optimize here the loss function. We can reduce the loss function with the help of penalty term. So the loss function for logistic regression is shown by this notation, which is similar to the J symbol here, right? So we can here shrink the value of W, that is the coefficient value, with the help of either L1 norm or L2 norm regularization techniques. So this works like your regularization technique that we discuss in the linear regression model by adding this penalty term, right? That by multiplying this penalty term with the weight function, either using L1 norm or L2 norm, we can update the value of the W to find the optimal solution or to reduce the loss function, right? To optimize our logistic regression model. I hope so you are clear with this. The next topic, that is perceptron, I will cover in the next session. Thank you.